Global warming is becoming a greater issue and will continue affecting the world we live in. Because of this, it is important for us to monitor and control the effects of greenhouse gases such as carbon dioxide. INSPECO contributes to the global warming crisis solution. Organizations such as NASA have been using LiDAR systems that orbit Earth and detect CO2 gas concentrations. They have incorporated discrete components, and the downside to these systems are that they are big and bulky and consume lots of power. What Impress LiDAR proposes is to decrease the cost, size, weight, and power by using integrated photonic technologies. Impress LiDAR is a research project done at UCSB that has already developed a photonic integrated circuit, or PIC, for the LiDAR system, but is in need of a user-friendly control system. This is a high-level block diagram of the Impress LiDAR system, which has the control electronics and the PIC. The photonic components of the PIC, which are shown in yellow and orange, are controlled by the hardware components, which are shown in gray. But for this project, we'll be focusing on the control electronics to control and monitor the PIC. The PC is used to develop the firmware and run the user interface. It also sends commands to the FPGAs from the interface. The FPGAs then send and receive data from digital to analog converters, or DACs, which convert set voltages to laser drivers and temperature controllers. The laser drivers and temperature controllers control portions of the PIC. And now let's show how the user can set voltages to the DACs using the interface. The user can first select the laser driver, which finds the DAC and generates an address for it. The user can then input temperature for the temperature controller or current for the laser drivers. Then the voltage is calculated from the information and converted into binary data. This data is then sent through I2C communication to the corresponding DAC. Here we're showing how the data is being processed from the interface, and this shows how the data is being sent sequentially inside the firmware. The user-friendly interface has two sections, the control panel and the output indicators. The control panel allows the user to enter the desired current or temperature while selecting the section of the PIC. The user can then send this information to the firmware where it receives the DAC address and data to send. The output indicators allow the user to see voltage levels that are set by the DACs at the corresponding laser drivers or temperature controllers. The intentions were to be tested on the PIC, but so far we have only been able to test on LEDs. Because we are able to control the LEDs using the interface, this proves that we can control the Impress LiDAR system fairly easily. And now we can replace big satellites with small satellites. Thank you for watching.